Okay, so this is continuation of our discussion in chapter 3, the derivative. So in this lecture, we will be discussing about the derivative of some algebraic functions. So we will derive some formulas later on that we will be using in taking the derivative of algebraic functions. So the first type of algebraic functions that we will take the derivative is the constant function. So what's the derivative of a constant function? So when we say constant function, the graph of the function should be a straight or line, just like this one. So this can be considered as a constant function. So usually we denote this one y equals, if this is the distance from here to here is a certain function or constant c, y equals c. Or we can also say that this is f of x equals c. It's a constant function. Now if we want to take the derivative of this one, so we apply the definition of the derivative. Remember, c here is any number, any constant real number. Now, if we apply the definition, the derivative, so dy dx, let's use this notation, dy dx, derivative of y with respect to x, this is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. Now here our f of x is just equal to c. F of x is just equal to c. So if we take f of x plus delta x, there's no x in the function, so it's just also be equal to c. Then if we substitute this one to the definition, this will be the limit of f of x plus delta x, which is c, minus f of x, which is also equal to c, divided by delta x as delta x approaches 0. Then, if we take the limit now of this one, c minus c, is this equal to 0. 0 divided by delta x is also 0. So we can now conclude that the derivative of a constant is just equal to 0. And it makes sense. Why? Because when we say constant, it's just constant. If we remember the definition of a derivative, derivative is a change. It's the change of y with respect to the change in x. So if it's constant, then it means there's no change. If there's no change, then therefore the derivative is also equal to 0. So it makes sense. Because the slope of this line is equal to 0. It's always equal to 0. So the derivative of a constant function is also always equal to 0. Okay? So for example, if y is equal to 34, determine y prime or dy dx. So we can now say that dy dx here is just equal to 0. Why? Because 34 is just a constant. It's just a constant number. So any constant number, if you take the derivative, it's always equal to 0. And now let's go to the second type. We have the identity function. So identity function is in this form is just equal to y equals x. So it's identity, they are equal, or this is also the same as f of x. So this is not constant. So if we try to draw the graph of this one, the graph is a straight line, an inclined line. And these values of x here should be equal to the value of the y. That's why it's called identity. They are equal. Now, if we, again, apply the limit, we take the derivative of this one, dy dx, this should be equal to the limit of f of x plus delta x. So what is f of x plus delta x? So there's an x in the function, so we just change it with x plus delta x. So this will be f of x plus delta x minus f of x all over delta x as delta x approaches 0. If we substitute now, f of x plus delta x and f of x, this will be equal to the limit of x plus delta x. This is our f of x delta x. Then we subtract f of x, which is this equal to x, all over delta x as delta x approaches 0. So we can simplify this one. X minus x will cancel out. Then delta x divided by delta x is this equal to 1. So this will be the limit of 1 as delta x approaches 0. So if we apply the limit of a constant is equal to the constant, the property of limit. So this is just equal to 1. So the derivative of y, or y equals x, derivative of x dx is equal to 1. So it may also make sense because dx divided by dx is equal to 1. Dx over dx. Okay. That's the identity function. Now let's go to a linear function. Number 3. What's the derivative of a linear function? Linear function. So it's not identity. So it can be any in the form of slope-intercept form. If you remember slope-intercept form, y equals mx plus b. Or let's just use ax plus b, where a and b are constant. A and b are constants or real numbers. Real numbers. Now, if we want to determine the derivative of this type of function, then let's derive it. So derivative of y with respect to x. So we can say that this is our f of x. So this will be equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. So again, we need to determine f of x plus delta x. So what is f of x plus delta x? This will be equal to a times x. We change x with x plus delta x plus b. Then we substitute now. We have here the limit of f of x plus delta x, which is this one, a x plus delta x plus b. Then we subtract f of x, which is ax plus b, all over delta x as delta x approaches 0. So take note, I put a quantity here because the negative here, the minus, is the whole function should be a negative. So we need to distribute the negative to whatever is inside the quantity. So sometimes students forget to put quantity and it will become minus ax plus b, which is wrong. It should be minus ax minus b. You need to distribute that negative inside the quantity. Rule of grouping quantities in algebra: when you remove the quantity, if it's preceded with a negative sign, you need to change all the sign inside that quantity. So remember that. So this will be equal to, simplify further, delta x approaches 0. We can distribute a here. So it will become ax plus a times delta x, then plus b. Then we can now distribute that negative, remove the quantity, so ax minus b all over delta x. Then we can cancel out ax here. We can also cancel out b here. And if we divide a delta x divided by delta x also will cancel out. So this will be 0, 0, 0, and this will be 1. Then to simplify this further, the remaining terms will be the limit of a as delta x approaches 0. So if we take the limit of a constant, remember a is a constant, there's no delta x inside that one, so it's just equal to a. So the derivative dy dx now will be just equal to a. And also if you where's b? Where's the constant b? Where does b goes? If you remember our discussion, we can distribute the derivative of a functions. So the f of x plus ax plus b, this can be treated as two functions, ax and b, a constant function. So if you take the derivative of this derivative with respect to x of ax plus b, this is just equal to the derivative of ax with respect to x plus the derivative of b with respect to x. So if you take the derivative of b, it's a constant, this will be equal to 0. So this means that the derivative of ax plus b is the same as the derivative of ax, which is equal to a. So this is also the same as the derivative of ax, which is equal to a constant a. So if you take an example, if y is equal to 3x, determine dy dx. So here we can see that a is equal to 3. There's no b here, you can put plus 0. So dy dx here is just equal to 3. It's just equal to the coefficient of x, just like what we derived here. Remember ax plus b, or simply ax. So if the problem says y is equal to 3x plus 5, so if you take the derivative of this dy dx, it's the same as the derivative of 3x with respect to x plus the derivative of 5 with respect to x. So we know that the derivative of 3x is 3 from here, this one. And we also know that this is equal to 0 because 5 is just a constant function, so plus 0. So we can conclude that the derivative of y equals 3x and the derivative of y equals 3x plus 5 is just the same, it's equal to 3 because the derivative of a constant is also 0. Now, next, what happens if we increase the degree of the function dx? So next, derivative, so this is now number 4, I think number 4. Derivative of functions to the nth power. So in general, what's the derivative of a function to the nth power? So if y equals x raised to n, and this is called the power rule. So we can derive it using the definition of a derivative. So first, instead of y, we can use f of x. And next, we need to know f of x plus delta x, as usual. And that will be equal to x plus delta x raised to n to the n power. So if we apply now the definition, dy dx will be equal to the limit of f of x plus delta x, which is x plus delta x raised to n, minus f of x, which is equal to x raised to n, all over delta x, as delta x approaches 0. Now, to evaluate this one, we need some uh, properties or theorems in algebra. How do we expand x plus delta x raised to n? So in algebra, we have what we call the binomial theorem. Binomial expansion. We can expand a binomial to whatever power we want. So x plus delta x, according to this theorem raised to n, is just equal to x raised to n plus nc1. Is a combination. This one will be discussed in your algebra. I hope you know this one. Binomial theorem. X raised to n minus 1, then multiply it with the second term, delta x. Then as you decrease the exponent of x here, you increase the exponent of delta x. So this will be plus n c2 x raised to n minus 2. So I decrease now the exponent of x. Then I multiply it again with delta x, but this time we need to raise it with, this is 1, so here will be 2. Then you continue that, plus dot, 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 until the constant part, or the last part, delta x raised to n. So you can use that one. So if you remember, for example, a plus b squared. So this is the first term, x raised to n. Our x is a, so this is a squared. As nc1. What is nc1? It should be 2c1. Our n is equal to 2. X, our x is a raised to 2 minus 1, so this is 1, and you multiply it with b raised to 1, then plus 2c2, then you multiply it with a raised to n minus 2, so this is 2 minus 2, then you multiply it with b squared, and that's it. The last part, this will be equal to 0, and this will be equal to, this will be equal to 1. A raised to 0 is 1. This is also equal to 1. You can use your calculator in solving this combination. There's a function in the calculator to see when. And actually, this is the definition of this combination. NCR is this equal to n factorial all over r factorial times n minus r factorial. So what's factorial? Factorial means, for example, 5 factorial, this is the same as 5 times 4 times 3 times 2 times 1. That's factorial. So you can use that definition, or you can use your calculator directly in binomial theorem. But we will not use this one because we want to expand x plus delta x raised to any power n power. Okay, so here nc1, any nc1, if you try to you take any number, you take the combination to 1, this is always equal to n, because of the definition that I gave you, n factorial divided by r factorial times n minus r factorial. Then, if we apply now this one here in the limit, so we will have dy dx will be equal to the limit as delta x approaches 0 of f of x plus delta x, which is equal to this one, x raised to n plus nc1, or that's just equal to n times x raised to n minus 1 times delta x, then plus nc2 times x raised to n minus 2 times delta x, then plus dot until delta x raised to n. So this is f of x plus delta x. Then we need to subtract x raised to n. So x raised to n. This is f of x divided by delta x. So here, we can cancel out x raised to n. Obviously, the first term here will cancel out. And the remaining terms, if we try to observe what will happen to the remaining terms. So here, delta x approaches 0. We have nx raised to n minus 1 times delta x. So if we divide it with delta x, that will be just equal to n minus 1. Then if you look at the remaining terms, here, this is actually squared, this is squared. So plus nc2 x raised to n minus 2 times delta x squared divided by delta x. The one delta x will cancel out, so there will be remaining delta x. Then so on. So all the terms from here up to delta x, this will be n minus 1, will have the term delta x. So all of them will have delta x. All of them from here to here. Why do we need to know this one? Because we are, remember, taking the limit as delta x approaching 0. So if the term contains delta x, this will be equal to 0. So any function that is multiplied by 0 will always be equal to 0. So this means that all these terms will always be equal to 0. Why? Because all of them has a term delta x. So they are multiplied with delta x. So if you multiply it with 0 when we apply the limit, then all of them will also be equal to 0. So we can now conclude that the derivative of y, which is x raised to n, all over dx, is just equal to the limit of this term. This is just the remaining term, and there's no delta x inside this one. So the limit is just equal to n times x raised to n minus 1. And this is what we call the power rule. So this is a very useful rule or formula. Instead of going back here using the definition of a derivative, then you can now just use this formula that we derived using the definition. So let's take an example. If y is equal to x raised to 5 plus 8x squared minus 3x and plus 1, determine dy dx. Determine the derivative of y with respect to x. You can use the definition, but we already derived the formulas. If you forget the formulas, then you can always go back and derive them on your own. That's the purpose of this lecture. You don't need to memorize the formula, but here we will be using the formula. So solution. First, using the sum and difference rule. So what's the sum and difference rule here? We can distribute the derivative. So y equals x plus plus 8x squared minus 3x plus 1. So if we take the derivative, this is just equal to derivative with respect to x of this function plus 1. So the sum rule or difference rule, you can distribute the derivative. So this is just equal to the derivative of x raised to 5 with respect to x plus the derivative of 8x squared with respect to x, then minus the derivative of 3x with respect to x, and plus the derivative of 1 with respect to x. Then next, we try to eliminate the derivatives that we know here. We know that derivative of a constant is 0. So this term here will be equal to 0. Derivative of 1 with respect to x is 0. Then this one here, this is a linear function, 3x, or the derivative of ax. The derivative of a linear function, ax, is just equal to the coefficient of x, which is equal to 3. So this one is just also equal to 3. Then the two part here, this two part, we can apply the power rule. So what does the power rule says? The derived formula, x raised to n. You take the exponent, bring down the exponent, then you just subtract 1 with the original exponent. So for example, 8x squared. So this will be equal to, so before x squared, first x raised to 5. What's the derivative of x raised to 5? So first we bring down the exponent n, which is equal to 5, and copy x. Then it should be n minus 1, or 5 minus 1. Just like the formula that we derived here. Our n is 5, bring down 5, then raise it to 5 minus 1, or n minus 1. Then we add here, we can take out the constant first, 8. You can bring out the constant of the derivative. It's always multiplication. Then you multiply it with the derivative of x squared. So how do we take the derivative of x squared? Again, using power rule, bring down the exponent, which is equal to 2. Then copy x, then you subtract it with 1. So 2 minus 1. Okay? Then here minus a 3, then plus 0. So that's how we take the derivative using the formulas that we derive. You don't need to use again the definitions of the derivative using limit. You can just, if you are familiar with these formulas. So the derivative of y now with respect to x will be equal to, simplify, 5x raised to 5 minus 1, which is equal to 4, plus 8 times 2 is 16. X raised to 2 minus 1 is 1, and minus 3. So this will be the derivative of the function. Now let's take, before we continue with our example, there's another rule that we need to discuss. Or before we discuss that rule, we can take more, at least 2 more example. Let's illustrate the power rule, the product rule and the quotient rule. So next example, before we go to the next rule, if y is equal to 2x plus 3 and you multiply it with x cubed plus 2x squared minus 4x plus 5, determine y prime, or dy dx. This is another notation, y prime. So here, so obviously we have a product. This is y is the product of two functions, 2x plus 3 and x cubed plus 2x squared plus minus 4x. So these are the two functions here. So it's a product, so we can use the product rule. But also, another way to solve this one is, first you simplify it by distributing or expanding the functions. Multiply them just like that. But we can also apply the product rule directly before simplifying. Product rule, then simplify. So let's use the product rule. So remember, what's the product rule? The product rule says that if you have two functions, the derivative of two functions, let's just use u and v. U times v, where u and v are functions of x. U times v. This is just equal to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. So this is the product rule. So we can have 2x plus 3 as our u, and v is this one, x cubed plus 2x squared minus 4x plus 5. So dy dx now, applying the product rule. So let's take 2x plus 3 as our u. So just copy 2x plus 3. U is equal to 2x plus 3, and v is equal to x cubed plus 2x squared minus 4x plus 5. Then we need to know the derivative of u with respect to x. So this will be equal to, derivative of 2x is 2, derivative of 3 is 0. Next, derivative of v with respect to x. The derivative of x is x cubed. Bring down the exponent. Copy. Minus 1. 3 minus 1 is 2. Plus, bring down the exponent. Then we multiply it with the coefficient. This is 2. 2 times 2 is 4 times x raised to 2 minus 1. Then minus derivative of 4x is just the coefficient 4. Then plus 0. So we have now all what we need to solve for the derivative dy dx. So this will be equal to u, so 2x plus 3 times dv dx. So this one times this one plus this one times this one. Just cross multiply them. So times 3x squared plus 4x minus 4. Then plus 2 here times x cubed plus 2x squared minus 4x plus 5. That's product rule. Then we can simplify now. After applying that one, you can now simplify. So simplifying this one, you can still expand this one, or this is fine. 2x plus 3 times x, 3x squared plus 4x minus 4 plus 2x cubed plus 4x squared minus 8x plus 10. So if we take the product of this, then this one, so the result will be 6x cubed, 2 times 3x, 2x times 3x squared, so 6x cubed, plus 8x squared, minus 8x, plus 9x squared, plus 12x, minus 12, then plus this one, that's 2x cubed, plus 4x squared, minus 8x plus 10. And simplify. So dy dx now. will be equal to 8x cubed plus 21x squared minus 4x minus 2. So that's the derivative of that function. So that's product rule. Now, how about the quotient rule or the low di high, high di low? Let's take another example. If y is equal to the square root of 2 plus the square root of x all over square root of 2 minus square root of x. Determine dy dx. So there's a square root here. Remember in algebra, laws of exponents, the nth root of any x variable raised to m, this is just equal to x raised to m over n. So for example, if this is the square root of x, then it's the same as x raised to 1/2. So if it's a cube root of x, then this will be x raised to 1/3. If the cube root of x squared, this is the same as x raised to 2 over 3, where 2 is m and 3 is n. So that's the laws of exponents. So remember, don't be afraid when taking the derivative of a square root or a radical function, because you can always convert them into exponential form, just like this one. Then you can now apply the power rule. So it's the same rule again. So let's try to solve this one. Y equals square root of 2 plus square root of x all over square root of 2 minus square root of x. One way to solve this one is to, again, simplify first before you take the derivative. So to simplify, you can multiply the conjugate of the denominator. Then apply the square of a binomial, the difference of the square of a binomial. Or we can just directly use the quotient rule. So remember the quotient rule. The derivative of the quotient of a certain function f of x with, you divide it with another function. This is just equal to, so law di high, law is g's of x times the derivative of high, v high, so f prime x, minus high, f of x, times the derivative of the law, high di law, g prime x, all over law squared, g's of x. You square this one. So to apply this rule, we need to know f of prime x and g's of prime x. So we can denote that f of x can be equal to square root of 2 plus the square root of x. Then g's of x will be equal to square root of 2 minus square root of x. Then we need to determine f prime x. So what's the derivative of this one? Derivative of square root of 2. This is just a constant, so it's just equal to 0. Plus this one, this is the same as x raised to 1/2. Remember, this is the same as x raised to 1/2. This is x raised to 1/2. So n here is 1/2. So bring down the exponent, 1/2. Then copy. Then 1/2 minus 1, n minus 1. And that will be equal to 1/2 minus 1 is negative 1/2. So this will be 1/2 x raised to negative 1/2. And simplify further, if I don't want a negative sign, I can bring down that x. So this will be 1 over 2 times x raised to 1 half. Or x raised to 1 half is the same as the square root of x. So this will be f of prime x. Then for g's of x, it's almost the same. The only difference is the negative sign. So this will be 0 minus 1 half x raised to negative 1 half. Or g's of x will be equal to negative 1 over 2 the square root of x. Then we can now substitute this into our formula. dy dx now will be equal to log di. So this is prime. Our law is g's of x, which is square root of 2 minus square root of x. So this is log, or g's of x, times di, derivative of high, which is f of prime. So I multiply this one with 1 over 2 the square root of x. Then next is minus f of x minus high, which is square root of 2 plus square root of x. This is high, or f of x, times derivative of law, which is g prime x, negative 1 over 2 the square root of x. Then this one will be all over log squared, g's of x, square root of 2 minus square root of x squared. Then we can now simplify this one. Actually, this is now the derivative of that function, but we can still simplify it by expanding and canceling some terms. So here we can distribute square root of 2 or 2 square root of x. So this will be equal to square root of 2 all over 2 square root of x minus square root of x over square root of x will cancel out, and this will be just equal to 1 half. Then next, so this is minus and minus, so it will become a positive. Negative times negative is positive, so we can just make it plus square root of 2 all over 2 square root of x. Then plus square root of x will again cancel out, so that will be equal to 1 over 2 all over square root of 2 minus square root of x squared. Then to simplify it further, we can cancel out 1 half. Then this term is similar to this term, so they are the same. 1 half, 1 half, so you just multiply it by 2. So 1 half times 2 is 1. So that is just equal to square root of 2 over x over square root of x. The 1 half will cancel out. All over square root of 2 minus square root of x squared. Then simplify further. dy dx is now equal to, we can just make it square root of 2 over square root of x times the square root of 2 minus square root of x squared. This will do. You can also still simplify this one if you want. You can expand the denominator, square root of 2 squared minus 2 times square root of 2 times square root of x, then times the square root of x squared plus the square root of x squared. Then you multiply it again with the square root of x, but this is okay. So that is the quotient rule. Okay, so we go now with the another rule that will be very useful in taking the derivative of some more complicated functions. We call it the chain rule. The chain rule And we can also incorporate the power rule using a chain rule or general power rule. It's not just x raised to n, but any function raised to something, we can apply the general power rule. The chain rule is just the derivative of a composite function. So if we have a function of x, which is equal to, remember the composite function f of g, composed of g's of x. So if we take the derivative of this, and that is what we call the chain rule. So the derivative of f of x with respect to x now will be equal to the derivative of f of g's of x with respect to x. Then it's not yet done. We need still to multiply g's of x over dx. So this is chain rule. If we to make it more intuitive, we can just change our f. We can make it let y be equal to a certain function in terms of u, and u now is a function of x. So this is a composition. Again, we compose f in terms of g's of x. It's the same as capital F of x. So if we take the derivative of y with respect to x, now derivative of f of u is just equal to the derivative of y, which is f of u, but we take the derivative with respect to u because it's in terms of u, f of u. But we know that u is equal to g's of x. So the final derivative of this is not just equal to dy over du, because we want to solve for dy over dx with respect to x. So we need to multiply it with another term, the derivative of that function, and it will be with respect to x. So this is what we call the chain rule. And this is very, very useful, especially when we apply general power rule. So general power rule So if we have a function f of x, if our y is equal to f of x raised to n power, so it's not just x raised to n. So the whole function raised to x or raised to n. So if we take the derivative of this is just equal to n. You multiply it with f of x, general power rule, then you subtract 1 to the exponent. But because of chain rule, this is not yet done. This is just dy over du. So we need to multiply it with du dx, or the derivative of f of x with respect to x. So we need to multiply it with another derivative, the derivative of whatever is inside that quantity. That is the general power rule in terms of chain rule. So let's take an example to illustrate this one. Example. If y is equal to x plus 3 squared, then we want to determine dy dx. So applying the general power rule in terms of chain rule solution. So to do that, actually we can expand this one first before we take the derivative, just like what I've said before. Before you apply the quotient rule, the product rule, you simplify first. But actually we can solve it directly using the chain rule. Then you can now, after applying chain rule, you can simplify to whatever you want. So to do that, without expanding, but using the general power rule, or we can do first, we expand. Okay, we expand this by expansion without using chain rule and general power rule. Expansion y equals x plus 3 squared. So using the binomial expansion, this is x squared plus 2x times 3, so 6x plus 3 squared, 9. Then you take the derivative dy dx. This is just equal to the derivative of x squared with respect to x plus derivative of 6x with respect to x plus the derivative of 9 with respect to x. So this will be equal to 0, this will be equal to 6, and this will be equal to 2x. So dy dx will be equal to 2x plus 6, and it's done. That's the derivative of y with respect to x, derivative of x plus 3 squared. But using the chain rule and the general power rule, chain rule and general power rule, without expanding first. So here, we can let, so this is y equals x plus 3 squared. We can let f of x to be equal to x plus 3. So that's the function. Or you can use u if you want. Just like the other books uses. They use u. Then, so this will be y equals f of x then squared. Then if you take the derivative of this one, so the derivative of y with respect to x now will be equal to, so first we bring down the exponent, then copy f of x, then you subtract it by 1. But it's not yet done because it's the chain rule. There's still f of x here, so you still need to multiply it with the derivative of f of x with respect to x. And what's the derivative of f of x with respect to x? Remember, f of x is x plus 3. So what's the derivative of that? Derivative of f of x with respect to x now will be equal to, so derivative of x plus 3, derivative of x is 1 plus derivative of 3 is 0, so it's just equal to 1. Then if you substitute now this one, so dy dx now will be equal to 2 raised or times f of x, which is x plus 3, so this is x plus 3 raised to 2 minus 1, which is just equal to 1 times 1. Then simplify dy dx now will be just equal to 2 times x, 2x, 2 times 3 plus 6. So it's still the same answer, 2x plus 6. So here, our answer is 2x plus 6. Here, our answer is also 2x plus 6. So if in this type of example, the advantage of a chain rule and general power rule is not highlighted. So if we take another example here, so that you can appreciate the chain rule here. If y is equal to 2x minus 4 raised to 7, determine dy dx. So here we cannot use, you can use if you want the binomial expansion, but it's harder for us to expand this one using the binomial expansion. It's a longer solution. So we only can use, or we can use the chain rule or general power rule here instead of expanding first. So again, we let f of x to be equal to 2x minus 4. Then we need the derivative of f of x. with respect to x, it's just equal to 2. Then we can now apply the chain rule. dy dx now, dy dx will be equal to, so it's 7 raised to 7, so bring down the exponent. Then you multiply it with f of x. Then you raise it with 7 minus 1. Then you multiply it again with the derivative of that f of x with respect to x. So that's chain rule. Then simplify. So we have here 7. What is our f of x? It's just equal to 2x minus 4. It's just equal to 2x minus 4. 2x minus 4 raised to 7 minus 1, which is 6. Then you multiply it with the derivative of f of x with respect to x, which is 2. You multiply it with 2. Then simplify further. Now the derivative dy dx will be equal to 2 times 7, and that's 14, times 2x minus 4 raised to 6. And that is chain rule. That is chain rule or general power rule. More example. And this example, more example. If y is equal to x cubed minus 2x squared plus 5x plus 3 squared, determine dy dx. So again, it's not practical to simplify this further by expanding this function. It's hard to expand this one because it's not just a binomial, but it's a polynomial. So we use the chain rule or the general power rule directly. So again, we let f of x to be equal to x cubed minus 2x squared plus 5x plus 3. Then we need to determine the derivative of this, f of x, and with respect to x. So this will be equal to derivative of x cubed, bring down the exponent, then subtract it by 1 squared. And minus, bring down the exponent, you multiply it with the coefficient, it's 4, x raised to 2 minus 1, x raised to 1. Then plus the coefficient of x, 5, plus derivative of 3 is 0. Now we know this one, we can apply the chain rule. dy dx now will be equal to, so here our f of x is this one squared, so bring down 2, then you multiply it with f of x. What is our f of x? We can directly, instead of writing that, we can now directly just write the value of x, f of x. X cubed minus 2x squared plus 5x plus 3. Then this is raised to 2 minus 1. That's the power rule. But still not done applying the chain rule. Multiply it with the derivative of f of x, which is this one. 3x squared minus 4x plus 5. So this is from here. And now you simplify this. So we have 2 times x cubed minus 2x squared plus 5x plus 3 raised to 2 minus 1 is just equal to 1 times 3x squared minus 4x plus 5. So dy dx will be equal to, we can distribute to 2x cubed minus 2 times 2, 4x squared plus 2 times 5, 10x, is 2 times 3, 6, times 3x squared minus 4x plus 5. And this will do. dy dx is equal to this. Let's level up. Harder example. If y is equal to this one, square root of x plus 2 plus square root of x minus 2 all over square root of x plus 2 minus square root of x minus 2. Determine dy dx. So to solve this one, we can actually simplify first before we apply the derivative. So how do you simplify this one? Remember the conjugate. We can multiply the conjugate of the denominator. And we can apply the rule a plus b, special product, a minus b. This is the same as a squared minus b squared. Okay, so our denominator is, if this is our a and this is our b, and that's minus, we need to multiply it with a plus b to make it a squared minus b squared. So let's do that. X plus 2 minus square root of x minus 2. So multiplying the conjugate. So this will be x plus 2, then it should be plus x minus 2. So we multiply it in the denominator, so we need to multiply it also to the numerator to multiply it by 1. Then we can now simplify, conjugate. We can apply this special product here, and this will be equal to a squared, so x plus 2 squared is just x plus 2. Square of square root is that one. Then minus b squared, so x minus 2 is x minus 2. Then at the numerator, it's the same term, so we can just square this. Square root of x plus 2, square root of x minus 2, then you square it. Then here, look at this one, we can cancel out x minus x. Then we have 2 minus negative 2 is 4. This one is equal to 4. So positive 4. So the simplification now, also we can expand the numerator. So this will be, y will be equal to, you square the first term, so x plus 2. X plus 2, then it's plus, so plus 2 times x plus 2 times x minus 2. Then plus square the last term, so it's just x minus 2. Then all over 4. So to simplify this further, this will be equal to we can make x plus 2 and x minus 2 inside. We can put it inside the square root. So it will be x plus 2 times x minus 2. So this term here, it's the same as the square root of x plus 2. You multiply it with x minus 2. You can do that because they are both square root. They have the same exponent. Then we can again apply the special product here, a plus b times a minus b. It's just equal to x squared minus 2 squared, or it's just equal to 4. So applying that, then we have x plus x, so we have 2x. Then plus 2 minus 2, this will cancel out, plus 2 minus 2. Then we have plus 2 times, you multiply it with this one, the square root of x squared minus 4 all over 4. And we can still simplify, we can cancel out 2. So y will be equal to 2 over 4, and that's 1 half. 1 half x plus 1 half the square root of x squared minus 4. Then we can now apply the derivative from here. So this is much simpler than the first one. So we can take the derivative separately for the first term and the second term. The derivative of 1 half x is just 1 half, but the derivative of 1 half the square root of x squared minus 4 is different. So what's the derivative of that? So here we can let f of x to be equal to x squared minus 4. Because this is the same as raised to 1 half. So the derivative of f of x, derivative of f of x with respect to x is just equal to 2x. So if we take the derivative of the square root of f of x with respect to x, remember x squared minus 4 is our f of x. So we're taking the derivative of this term. We can just disregard 1 half first. We just multiply it later on. So this will be equal to, it's the same as the derivative of 1 f of x raised to 1 half. Raised to 1 half over dx. So we apply chain rule here. So bring down the exponent 1 half and copy f of x, then 1 half minus 1. Chain rule, we still need to multiply the derivative of f of x with respect to x. And this is actually equal to 2x here. This is 2x. 1 half minus 1 is negative 1 half. And f of x is equal to this one. So we have now the derivative is 1 half, multiply it with f of x, x squared minus 4 raised to 1 half minus 1, which is negative 1 half. Then you multiply it with 2x, and 2 here will cancel out. So we have now x over, so this will be x all over, we bring down the negative exponent, so this will be square root of x squared minus 4. X raised to 1 half is the square root. So this is the derivative of this one here, but we need still to multiply it with 1 half. So let's go back to this problem. dy dx now will be equal to the derivative of 1 half x is 1 half plus derivative of this one 1 half, and this one is x over the square root of x squared minus 4. And this will be our final value for the derivative. Okay, so that's the derivative of some algebraic function. So the next part of this chapter, we still have 2 topics. We have higher order derivatives and also the implicit differentiation. So okay.